All right, welcome to the third section 5.5 video. First of all, apologies for the abrupt ending to yesterday's video. The bell rang. I am a high school teacher, and I suddenly realized I had students coming in, so I shut it off. We'll finish the recap at the end. I started the recap, and then it's not really necessary at this point. Guys, let's talk about approximating roots using linearization. Let's say that I want to calculate the square root of some number. What I know about this is that this is very close to the square root of 125. Well, I take that back, 121. Well, I know the square root of 121. I know that that's 11. So I expect the square root of 123 to be something very close to 11. So let's linearize this around square root of 121. We'll start with a equals 121. My function is the square root of x, which means that the square root of a is 11. And the derivative of my function, of course, is 1 over 2 root x, which means that the derivative of a is 1/22nd, and my linearization is 1/22nd x minus 121 plus 11. So now I can approximate any number near 121. Linearization at 123, in other words, the square root of 123 is approximately equal to, well, 1/22nd of 123 minus 121 plus 11. Well, that's 2/22, which is 1/11th, 11 and 1/11th, which is 11.01. Excuse me, 11.09 recurring. 11.01, of course, would be 11 and 1/11th. Calculating the square root of 123, what do I get? I get 11.09053651. My error is less than 10 to the negative 3. And you can do the error calculation to discover that. Interesting. I would have said it was less than 10 to the negative 2. The book said it was less than 10 to the negative 3. Let's do an actual quick calculation. Absolute value of 11.09, and I'm just going to type in a bunch of 9s, minus 11.09053651. I get 0.009, which is less than 10 to the negative 2. Either I read the book wrong or the book is wrong. All right, let's do another example of approximating root. This time we'll do the cube root of 123. Well, we know that this is near the cube root of 125, and we know that that's exactly 5. So a is 125. F of a is 5. The derivative, well, let's define my function first. F of x equals the cube root of x, which means that the derivative is equal to 1 over 3x to the 2/3. And we'll fiddle around with that in a minute here. Well, that means that f of f prime, the derivative at 125, Equals 1/75th. And when I say we'll fiddle around with that, there are a lot of ways to write 3x to the 2/3. And one way is obviously 3, the cube root of x squared. Well, I don't particularly want to take the square of 125 and then figure out its cube root. Or it is 3 times the cube root of x all squared. And this one actually works out better because I've got 125, cube root I know is 5. 5 squared is 25, and I get 1/75. So my linearization, and that's just an example. It's just an example of how you can do these things mathematically in your head by changing orders. So we get 1/75th, x minus 125 plus 5 is my linearization. And of course, the linearization means that the cube root of x is approximately L of x for values of x near 125. So let's find the cube root of 123. We get 1/75th. 123 minus 125 is -2 plus 5, which is 4 73/75. And if we decimalize that, we get that this is equal to, let's see, approximately, well, 4.97 and then a bunch of 3's. Cube root of 123 is approximately that. If I calculate the cube root of 123, I get 4.973189833. And again, if you notice that the error is in the 4th decimal place, so the error is less than 10 to the -3. Once again, pretty darned accurate. Okay, I'm going to stop this video here. I think there will be a 4th video upcoming, but I'll leave this here. If you are in my class, hold your breath. See how long you can hold it while I find the problem that I want you to do right now. The problem that I want you to do right now is exercise 11. So if you're in my class, go ahead and do exercise 11, and we'll be back with the next video. Thanks for watching.